Since this is the last reporting session in this 5-year SCRI, we wanted to start with just a little bit of history and of our zebra chip research in our program, and then finish with some 2014 results. Back in 2000, we had plots down in South Texas with Jack Wallace, and he and his dad took us around to some of their fields to look at a problem that they were having. At that time, they had individual plants sporadically around the field being affected by something. They were just collapsing and going down. Upon digging them up, looking at the tubers, you would see that they were brown inside. So upon shipping, they looked like this. We didn't have any idea what it was at the time. It looked like maybe it could be an insect, or could it be a seed issue? We weren't sure. This was our introduction into the world of zebra chip. At that time, we were looking at all of our advanced chip selections by chipping, and by 2004, we were starting to see zebra chip in our material, and by 2006, it was readily being seen. In 2006 and 2007, Goolsby and Mignonezza were reporting that psyllid was indeed involved in the disease. And of course, this is what we were seeing in 2007 in the field. They were, of course, attracted to the center pivot wheel marks on the edges of the field and such. By 2008, the New Zealand group, of course, had identified the Liberibacter psyllid association. And of course, by 2007, in our program, we had no choice but to screen everything. Oops, something happened here. Something's out of order. Uh-oh. Something's out of order there. Our overall objective was to evaluate a wide range of germplasm tolerance and resistance to zebra chip in order to identify and or develop varieties for the industry which can be more successfully grown when and where the conditions for zebra chip are present. It's to be understood that all of our zebra chip research has been done in association with our breeding program, and quite frankly, over the last several years, it's been a major component of it. The other thing is that all of our evaluations are chip evaluations. We would like to use PCR, but for the numbers that we're handling, it's just not feasible. So anyway, that first slide that we were just looking at was a list of all of our trials that we had at Spring Lake in 2008 and 2009. And it represented about 1,000 different plots and about 200 different selections. All of those were chipped and evaluated, and it wasn't only just Spring Lake, but also Dalhart. So it was quite an effort back in the day to do all that. Our rationale is that ideally tolerant and resistant cultivars are the optimum long-term solution. And those cultivars are important in research activities for other researchers that are working with the disease. Our program over the years has worked with other groups in supplying material, planting and harvesting of trials, as well as evaluations. As Dr. Miller states in his introductory plant breeding course, you always start with the most advanced material that you're screening, because they can contain all the attributes that you want in a variety that's acceptable to the market. I don't know where that was going. Oh, we also did some clonal selections, as well as devised a breeding methodology for handling some of our crosses that we are getting into. In our clonal selection, we just followed some of these green plants, dug them up, and looked at them over the years. This ZC4 is looked fairly interesting, but again, it's very inconsistent in results from year to year. We did develop this fast-track methodology for working with our material that we're crossing and bringing into our program. We are using a modification of that in our program currently. We all are aware of the disease triangle here. And like we've been discussing the last 2 days, this is what we've all been dealing with, is multiple haplotypes of both the vector and the pathogen. And then for us, the differences that we're dealing with in the varieties to these, as well as the year-to-year differences in the environment. Again, all of us working with zebra chip know it's a complicated situation. As a breeding program, though, we also have to add the complexity of the tuber and chip appearance and its market acceptability, as well as some of the difficulties in hybridization due to a lot of incompatibilities. This little study here shows some of the ideas that we had behind the idea about end use of the variety. And it was just a quick and dirty study we did several years ago where we chipped, baked, and microwaved and boiled so lines that had been infected outside of the chip there. The consumer really wouldn't notice that there's a real problem. To the producer, of course, that's a yield reduction and a possibility of a whole disaster. Going on to our 2014 investigations, we had cage trials down in Weslaco. Weslaco is in the South Texas, right on the Mexican border. And then up in Spring Lake, which is on the high plains, and it's about 4,000 feet. It's a temperate location. College Station to Weslaco is about 7 hours, and it's about 8.5 hours to Spring Lake for us. Oops. We tested about 58 clones in Weslaco, and of those that passed our test there, we supplemented those with some more that we received from the potato gene bank, and we ended up with 50 different clones that we tested at Spring Lake. We planted the second week of January in Weslaco and the second week in May in Spring Lake. We put the insects on about 60 days after planting in Weslaco and a little bit earlier at Spring Lake because it was warmer and the plants were a little bit earlier. Both cases we removed the insects after a week and then harvested the tubers 42 days after infection in Weslaco. And then we waited somewhat later and harvested 81 days later in Spring Lake. We used 4 insects per plant in Weslaco and 3 per plant in Spring Lake. This is a shot of our field in Weslaco, and those are palm trees in the background. It's a pretty nice place to be in January, but rather unpleasant in late April. One thing that we do differently this year was we use the little bag method where we place the insects in a little mesh bag, which was placed over an individual leaf in the upper third of the canopy, and those were left on for a week and then pulled off. When we pulled these off in Weslaco, we brought them in and looked at them and actually looked for live insects as well as egg laying. And again, if you have insects after a week, you would assume you have infection. All of the insects we used were from Don Henne's colony, which were 70% hot. And that's just showing some of our potatoes that we got out of Weslaco. At Spring Lake, you can note the background there, there's nothing. But anyway, it's an interesting environment to work in. It was really quite hot that day that we built these cages. Again, we used the same protocol that we used in Weslaco, where we put the insects on about the same, et cetera. Only thing different is that we did harvest these guys somewhat later. It was 81 days after after infection. We received these clones from Rich Novy. The top 3, Defender, A02449 and A05214, were late blight resistant clones. We were interested in those because after visiting with some citrus and pepper colleagues, and especially the pepper colleague, he indicated that a lot of times with late blight material in peppers, oftentimes a lot of other resistances are carried along. Unfortunately, these guys really didn't look that good for us this year. These 2 PALB lines are cold sweetening resistant clones, and we got kind of interested in cold sweetening, thinking that, well, cold sweetening means that they'll come out of storage and can be chipped right out of storage without reconditioning. And our thought there was, well, maybe they wouldn't have if after being challenged with the Liberibacter, that they wouldn't darken like that after being chipped. Unfortunately, both of these guys kind of dropped out on us this year. The next two, PA92A08 and A05379, were both parents or involved in the parentage of the next clones that I'll be talking about that we received from Oregon State. The PA92A08 had very light, a light reaction for us, and the next one did not do as well. I included the 003315 again this year because Rich had sent it to us last year, and it is a cold sweetening parent line that he's used in the past, and Joe just talked about it in his talk, and I think Rich will be talking about it in his. And it looked good for us last year, and it performed well again this year. Well, these are my chip pictures. They're not quite as fancy as Joe's, but, you know, it'll work. These are the controls for all the chips that were done in Weslaco trial. And then those would be the controls in the boxes that were done at Spring Lake. Spring Lake will always be on the right, Weslaco on the left. This is the PA92A08. In Weslaco, we didn't get any reaction. Again, these were harvested 42 days after infection. You know, all the literature says there should have been, you know, we should be able to see results, and here it's pretty light. At Spring Lake, however, after 81 days, we did get some zebra chip. But again, it's what I would consider a light reaction. This is the A03315 in Weslaco, the control in Spring Lake, and then the samples that were chipped. We received 13 clones from Oregon State last year, and those 13 clones had been selected from Oregon, here in Oregon, well, we received those from Brian Snyder, and they had been selected out of a field, a nursery of theirs that had been hammered by zebra chip in 2011. We tested them in cages last year, and out of those 13, we selected these 3 as having light reaction. This is 7781-2. Again, Weslaco is a fairly light reaction, but we do have a pretty good reaction in Spring Lake. I'd probably end up dropping that one. This is the 7793. Again, we ended up with a fairly dark reaction in Spring Lake, and that one will probably go. The one that looked the best, believe it or not, is this one, the 7783, and this is out of Spring Lake. It's a fairly light reaction. All 3 of these guys are russets, and they're not particularly good chippers to begin with. We received some clones from Shelley Jansky that had a lot of diverse species material in their background, and you can see the majority of these are diploids. There was one of these, the C545, a diploid verticillium resistance line that looked okay for us down in Weslaco. Again, comparing from the control to the chip, you know, they don't look very good chips anyway, but there isn't a whole lot of difference between the control and the test. We did not receive enough seed to be able to double check this one in Spring Lake. We did test some additional clones that we received from the National Chip Trial, several from our program, some from the Wisconsin program, and from the Potato Gene Bank. This one in particular, which I would call a best of trial, as Creighton would say, a BOT, had the lightest reaction of anything we saw this year. It's a B1992. It's an advanced clone that's in the National Chip Trial. And then this was one, Canasto is one we received from the Potato Gene Bank. It's a little bit dark, but you know, it's some of the better ones that we could see. Again, this is very similar to what Joe's saying. You know, we're looking at tolerance. We have screened close to 1,000 cultivars and have found varying degrees of tolerance, though we're not seeing the level we'd like to have seen. Crossing and selecting is underway using identified tolerant resistant clones. And selecting from breeding for zebra resistance is very labor intensive, since we've had to do all of our selecting now in cages since 2011. No immunity has been found, but various degrees of tolerance and resistance have been observed, and resistant varieties and selections have been incorporated into our crossing program, and progeny is being selected for evaluation. We are still trying to continue to set up a program with Dr. Rivera down in Mexico to take some of our material down there. They still have a zebra chip and late blight in this area of Mexico. And that reminds me of a saying, a quote from Dr. Tom Ramage, an old barley breeder in Arizona. He always said, if you're breeding in the absence of the disease, you're selecting for that disease. And I think that's kind of where we're getting to now. You know, as everybody's looked at this, we know the more we learn about it, the more complicated the problem appears to be dealing with the multiple haplotypes, the cultivars in the environment. One thing, if you want to say good out of this, it has been very stimulating to work with a broad range of scientists and producers in addressing this zebra chip problem. We do want to acknowledge the granting agencies and those that have really helped us through the years with our zebra chip research.